Hi, this is Farrokh Alemi from George Mason University talking about how do you debias advice on antidepressant AI systems. In this course, your task is to find the extent of bias and to identify the necessary corrections. These slides show you how we did so for African Americans, and we expect you to do so for other subgroups. Bias in our context is defined as advice that's not suitable for the population subgroup. So in essence, we are predicting the response to antidepressants, and if we find that they are not, such predictions are not appropriate for African Americans or a specific subgroup, then we will say there is bias. There are different ways of removing bias. The preferred method that we have is to remove it by creating different models for different racial or ethnic or other subgroups. The source of our data is All of Us Research Hub, which is coordinated by the National Institute of Health. The data we focus on comes from All of Us and is based on African Americans who are treated for major depressive disorders. In total, we had 6,945 such subjects. These patients underwent 27,525 different antidepressant trials. In their medical history, we could find 11,000 different conditions. 38% were in remission, 71% were female. The average age was 50 years old. The standard deviation of the age was 12 years. They received treatment for a total, on average, 255 days. They had prior episodes of depression, on average, 1.87 times. They had prior remissions, on average, 0.85 remissions. And they had tried prior antidepressant on average 1.74 times. The method that we analyze is per medication. So we are trying to predict the response to each antidepressant medication. We will use hierarchical modeling. In this approach, we re-examine the accuracy of a model when we add additional information, and we want to know if adding additional risk factors that are race-specific will improve the accuracy of predictions. The response to treatment was measured using discontinuation or change in medication prior to 10 weeks. So if you started on the medication and you abandoned it sometime during the 10 weeks, that would be considered non-responsive or poor response. But if you continued it up to 10 weeks, then that would be considered responsive. Now, people may continue with the medication that's not effective, but our data shows that this discontinuation measure is 96% of the time accurately reflecting patient-reported depression symptoms. The race-neutral factors in our models, we can refer to them as independent variables. These come from the existing AI model, which was derived from the general population that included African Americans, but it was majority white. These risk-neutral risk factors include prior experience with antidepressants, history of physical and mental illnesses, psychotherapy, psychiatric hospitalization, and many other factors. On average, somewhere between 50 to 250 variables were predictive of response to a specific antidepressant. Race-specific risk factors are any conditions in the patient's medical history which was not part of a risk-neutral model. Our method of analysis is shown here. We are talking about two different regressions. The first regression uses the race-neutral variables and tries to predict the outcome or the response to the treatment. The second regression adds in additional race-specific risk factors and sees if adding in more information changes the accuracy of the prediction. Here are some examples. For example, in predicting amitriptyline, we find that depressive disorder is predictive with a coefficient of -0.13. Mixed hyperlipidemia is predictive with a coefficient of 0.09, and so on. Notice at the very bottom, same antidepressant, no remission, that reduces the frequency that this time around the patient will respond to the antidepressant. These are just a sample of the coefficients. As I said earlier, for each regression, different models were tried, and between 50 to 280, 250 variables entered the models that were considered risk-neutral models. For amitriptyline, we had 1,984 cases. 780 of them had experienced remission, and the McFadden R-squared for race-neutral risk factors was 5%, and in cross-validation, the McFadden R-squared for race-neutral and race-specific risk factors was 7%. So not much of a large gain. Similarly, for bupropion, there was 2,658 cases, roughly 1,000 of them were in remission. 13% was the McFadden R-squared for race-neutral risk factors, and 12% was the revised McFadden R-squared after we add in race-specific factors. For nortriptyline, 804 cases, 277 remissions, but boy, look at this. Race-neutral risk factors, the McFadden R-squared goes from 15% to when we add race-specific risk factors, it doubles to 30%. So obviously, for this medication, the response depends on the race. For escitalopram, there was 2,031 cases, 791 remission. The McFadden R-squared was for 15% for race-neutral predictors, and for the combination of race-neutral and race-specific, the McFadden R-squared was 20%. Again, a big improvement in accuracy. So, what can we conclude from this? First, take a look at the amitriptyline and bupropion. Race-neutral risk factors are sufficient for these subgroups, but race-specific risk factors are needed for escitalopram and for nortriptyline. These slides have shown you how you can use hierarchical modeling to understand whether African Americans or the subgroup you're working with have different risk factors than the race-neutral population-wide risk factors.